This is the Mitsubishi iMiev, the world's first fully electric mass-produced car. A 100% electric car. It's a dream engineers have been fine-tuning for over a century. Yeah, early versions had promise. They'd be great for the environment, but they just weren't practical. Too heavy, too expensive, and too slow. In short, not quite ready to take over the road. That is, until now. The iMiev from Mitsubishi is aiming to change all that. Advanced technologies like a powerful single-gear transmission and a braking scheme that actually recharges the battery are winning over the skeptics. The key to it all is right here, the lithium-ion battery pack, the kind of technology that's inside your phone, only maxed out to power a car. The iMiev wouldn't be possible without it. Here, workers assemble the high-performance lithium-ion battery cells into 22 modules. They have 3 to 4 times the energy density of a lead-acid battery. The modules are then bolted to a steel frame, and the connecting wires are gathered with dozens of harnesses to make sure nothing moves. There's just no fooling around with the battery. The battery is hooked up to the computer brain of the car, which stops it from overcharging and shuts it down on the first sign of trouble. The battery pack is kept cooled or heated by circulating air from the car's climate control system, and the entire unit is waterproofed with a rubber seal in a resin shell. Altogether, nearly 150 bolts hold the battery pack together with layers of protection for safety. The value of the battery alone is nearly half the cost of the car. Of course, they would still need to design a car that could incorporate the new battery. Mitsubishi wanted something that could go more than 100 kilometers on a single charge. The problem, the farther you want to go, the bigger the battery needs to be. And that impacts size, weight, and cost of the vehicle. Eventually, they settled on a 16 kilowatt-hour battery that can travel 155 kilometers on a single charge. Next, they needed to package the EV components into a vehicle big enough to be functional, but small enough to be light and fuel efficient. To keep costs down, they looked within their existing fleet for answers. One possible choice was the innovative iCar, Mitsubishi's gas-powered Japanese K-Class vehicle. The original iCar look came from the pencil of Ichiro Otani, who won an internal design competition. Designers then had to modify the Japanese iMiev for the North American market. Then it became all about space, how removing catalytic converters, fuel tanks, and engines might or might not make room for electric components. It all started to look like a workable plan. The electric motor and inverter were mounted in the rear, where the gas engine was, and the battery was installed under the floor where the gas tank used to be. It all left enough room for 4 people and some rear cargo space. Extensive tests were carried out to make sure the iMiev wouldn't become a road hazard, starting with finding out what happens to that battery in a crash. There were punishing tests of durability, extreme temperature tests, even electromagnetic testing to make sure the battery wasn't sending out any harmful emissions of its own. To meet North American standards, the iMiev also had to be kitted out with safety and design modifications like a wider frame, longer bumpers, and improved aerodynamics. It had to pass real-world fleet testing in places as diverse as Hong Kong and Quebec. Not to mention make it through the worst of a harsh subarctic winter. And finally, when the engineers were satisfied, it was all brought under one roof. For mass production, the iMiev is put together on an ultra-modern assembly line side by side with the company's gasoline cars. There are 2,100 welding points on the iMiev, over 150 more than the gas-powered version made here. Only 18 welds are made by hand, a process that will be turned over to robots when demand for the iMiev jumps. 123 state-of-the-art robots flip the frame up to 180 degrees to optimize the welding. Once the welds are done, the bare metal doors are attached. The anti-rust dip, charged with 275 volts to make it adhere to the metal, forces the rust proofing to seep into every part of the frame. Then, workers paint the inside of the frame while robots take over the exterior. After the paint is dried, it's inspected in a tunnel of light for even the smallest flaw. At the Mitsubishi plant in Mizushima, Japan, full-scale production is underway. The assembly line is 628 meters long. 250 workers have 68 seconds to complete each task. Every car spends just 2.5 hours on the line, start to finish. On the assembly line, the car's unique technology and special features have to be integrated right alongside the gas-powered vehicles. The whole process is painstakingly detailed, especially here in an exclusive subsection off the main line, where two of the plant's most skilled workers put together the other critical EV components by hand: the electric motor, the transmission, the onboard charger, and the inverter or motor control unit. This is a state-of-the-art, high-performance, permanent magnetic synchronous electric motor. It has a maximum output of 49 kilowatts or 66 horsepower and an impressive torque of 196 newton meters or 145 foot-pounds. That's more than double the torque available in most subcompact gas cars. With electric, it's instantaneous. When you step on the pedal, the current goes right to the motor and the car takes off like a shot. And surprisingly, there's only one gear: iMiev's single-gear transmission that drives the car both ahead and in reverse. The motor's high torque output and ability to spin at 8,000 RPM means you don't need gear changes. When it's put in reverse, the motor spins backwards. In drive, forwards, powering the wheels at the same rate as the motor. When it's done, the entire unit is sent by robot courier back to the assembly line to be attached to the rear suspension, then lifted and inserted into the car. After a quick spin up the elevator, the iMiev is put through a very thorough inspection checklist. To be exact, 919 items. The car is checked for vibrations, headlights, turn signals, brake testing, stability control. A computer diagnostic is run to make sure the brains of the car are alert. An undercarriage review is carried out, critical for battery protection. There's even a typhoon-equivalent fluorescent water bath to check for leaks. After a short track test and a final visual inspection, the cars are wrapped in plastic and readied for shipment. From the moment they arrived on the streets in North America, these cars have been turning heads. It's an impressive package for sure, but electric vehicles are a huge sell. There are those nagging range limits, and quick charge stations are hard to find. Still, the upside is huge. Wicked torque, acceleration, and the silent drive. And most of all, never ever having to fill up with gasoline again.